As an introduction, our project focuses on how discrete structures concepts can be applied to organize a fair football tournament involving 8 university teams. The main challenge is ensuring that teams with different skill levels, playing styles, and ages are matched fairly. To solve this, we use combinations to generate possible match pairings and permutation to arrange those matches into different tournament schedules. By applying these concepts, we can create a tournament that is fair, balanced, and effectively organized.
A university is organizing a football tournament with 8 teams. The organizers need to ensure every match is fair and competitive by grouping teams correctly, determining all possible match pairings and scheduling those matches across available time slots on the match day.
For our first discrete structure concept, we used set theory to fairly divide the 8 teams in our tournament. Set theory lets us classify teams by shared traits, like rating, rather than by counting or ordering them, which is exactly what we needed at this stage. We treated all 8 teams as our universal set, T, with a cardinality of 8. Using the players' overall ratings, we split T into 2 subsets, G1 and G2, each containing 4 teams grouped by a similar skill level. Both subsets have a cardinality of 4, and both are proper subsets of T, meaning every team is accounted for, and none are duplicated or left out. This gave us a mathematically verified, balanced starting point before we got to scheduling.
Hello, my name is Isma Ahmed. For this project, I'll be covering the application of concepts. Concept 2, combination and combination. For this tournament, we can use both combination and permutation. Combination is used to determine the matches to be played by each team because the order doesn't matter. Using the combination formula, we can figure out that we have 28 unique matches. We can then use permutation to figure out the timing for each match. This is because the order of the schedule matters. The time slots can be figured out using the permutation formula, giving us 24 time slots. We can now divide the 28 matches within the 24 time slots. This ensures efficiency and fair scheduling.
Looking at our results, the set theory approach gave us more than just 2 groups. It gave us a mathematical guarantee of fairness. Because the cardinality of G1 equals to the cardinality of G2, both groups carry an equal match load. Because G1 intersected with G2 is an empty set, we know no team was accidentally placed in both groups, which in a real tournament would mean no double booking. And because both subsets are contained with T, we have confirmed every one of the 8 teams was included exactly once. Nobody missed, nobody duplicated. So the key insight is that set theory isn't just for organizing, it's a verification tool. It catches administrative errors before they happen. And since our grouping rule was based on rating similarity rather than random selection, the same method could be applied to build balance brackets in any tournament, not just football.
Hi, my name is Bernice, and I'm going to talk about the finding and insights, concept 2, permutation and combination, how these two concepts are applied in our football tournament scheduling system. First, we use the combination, which used when the order of selection does not matter. In a football tournament, Team A play with Team B and Team B play with Team A is the same. So the calculation is C bracket 82, means the number of way to choose 2 teams from 8 teams. Therefore, we get a result 28 unique matches in a single round robin tournament. This also means that each team will play 7 matches with no duplicate match are created. Next, we will use the permutation where the order is important. After determining the 28 matches, permutation helps us to arrange these matches in different time slots and playing order. This allows tournament organizer to create a schedule that avoid clash and ensure every teams have enough rest time between the matches. Overall, This calculation shows that combination and permutation is useful for determining the number of matches and organize a match scheduling efficiently. By applying this both discrete structure concept, we can create a tournament that is fair, well organized, and easy to manage. Thank you.
In conclusion, this project demonstrates how discrete structures concepts can solve real-world problems in sports tournament scheduling. Set theory helps organize the teams without duplication, while combination generate unique match pairings, and last but not least, permutation creates different tournament schedules. Together, these concepts ensure the tournament is fair and runs smoothly. And in the future, to improve our model even more, graph theory could be used to further improve scheduling efficiency and support larger tournaments with more teams. This is our project. Thank you.